My name is Mark Mosley. I'm an assistive technologist at Victoria Education Centre. Victoria Education Centre is a school for children who have physical disabilities and cognitive disabilities. I like to see the abilities that the person has rather than the disabilities. That's what the school's all about.
My name is Alexander Pasco. I am professor at the National Centre for Computer Animation in Bournemouth University in UK. My main profession is making software systems for geometric modeling. Shiva project is about using digital technologies for children with disabilities. So the primary goal here is to give children the tool for creativity. They have great imagination, but they have no tools almost to express themselves.
Children with disabilities find it very difficult to do art in a conventional sense. For instance, like sculpting with clay is very, very difficult for somebody who can't use their hands. And I thought this would be a great opportunity to develop a piece of software that would allow them to have these artistic experiences, but in a virtual sense, using technology that can compensate for whatever it is they're not able to do. So the Shiva project was designed to create a piece of software that enables people to create 3D models, and then we could print them out using a 3D printer.
They didn't understand 3D modeling until they've got the printer in the school, and suddenly the entire school realized, wow, it's a different world now.
My name is Lee McLaughlin. I'm a researcher in interactive geometric modelling, and my role in the Shiva project was to basically write the software. The most difficult part of the project is actually the whole user interface aspect. Most of us, the way that we interact with a computer is through maybe a touch screen or keyboard and mouse, but the children that we were dealing with, they're not able to do that. So the user interface system has to be able to cope with all of these different requirements.
You have to be careful. You have to make sure that by the time you put the software in front of somebody, it's working as well as it possibly can. You know, inevitably in any complex software there's going to be bugs in there. People with disabilities may think it's because of them that the software's gone wrong.
If the child fails to do something, they blame themselves. They don't blame software.
It was actually quite an exciting moment when Mark came back to us and said, you know, we've finally tested it with some students, and you know, yes, they were really enthusiastic about it and they really enjoyed the project.
The software was designed so that a variety of people could use it regardless of the disability that they had. We focused mainly on people who could use a mouse and keyboard, and we focused on direct touch, so people could use it through a touch screen and an eye gaze. This is a profile for people who have visual impairments. The combination of yellow and black makes it easier for somebody with a visual impairment to see. All the colours are configurable, the layout can be edited, the size of the cells, those things change, very much tailoring to the person's needs.
We basically want to reduce a complex process of 3D modeling to a very simple set of operations. The idea came, let's put a stick, and then they will drop these primitives on the stick. So it's a perfect one-dimensional modeling with 3D primitives. So this constraint was enough to give a balance between fun and not that difficult way of operating with the tool.
This is the Shiva software set up for somebody who uses an eye gaze system. So here we've got an eye gaze unit. So this tracks the person's eyes that's using the software. So the cells that they need to access are larger, so they're a larger target, easier to hit. It's a more simplified layout. If the eye gaze unit was enabled, I would be able to look at one of these cells and select shapes at the top. If I just touch one, you'll see that it adds onto the pole. They can manipulate the view to change how it looks. So there is complexity in the software, but that's all hidden, and the user interface makes it accessible in a fairly simplistic way, but also with the ability to create quite complex models.
When we saw the students actually using the software, it was at that moment that we realised that, yes, this project was worthwhile. It was actually enabling the students to do something that they couldn't do before. And that's what we set out to do.
At the beginning I thought, okay, it's another project, we will do it. Somewhere in the middle I thought we shouldn't drop the school. When the project finishes, how can we stop and say, okay, bye-bye, we go work for police or something else?
I think it's been a very worthwhile project. The main significance of such a system is being able to create something completely on their own. You know, independence is a big part of what the school tries to do. So, you know, a piece of software that can help somebody to create something independently will boost their confidence, make them proud about what they've created, and that's going to boost self-esteem, just make them feel better and have fun.
They were laughing, they were happy, they wanted to use this because it's kind of game, but unusual game or a toy. So it was very touching. Big men don't cry, but I would, yes.